Hello, 43 class. This is an example from section 2C. This is problem number 4. So we got two people running a 200-meter race, and this guy Jordan wins by 8 meters. And then they decide they're going to do it again. This time Jordan's going to start 8 meters behind the starting line. And they're assuming that they'll finish at the same time because he won by 8 meters. Alright, so let's see what happens with this second race. Alright, so here is Jordan. Here's the finish line. Jordan gets to the finish line, and when Jordan gets there, Amari is 8 meters behind. So that means Jordan ran 200 meters, and it means that Amari ran 192 meters in the same amount of time that Jordan ran 200 meters. Okay, so if you set it up, distance equals rate times time. That's what we're using here. All right, but we're using a different variation on it. So we have the distances. Okay, when Jordan gets done, Amari's 8 meters back, or 192 meters. So the time it takes these two guys to do this is equal. So what we're going to do is we're going to solve this equation, d equals r times t for time, for t. So to do that, you would just divide both sides by r, and you end up with time equals distance divided by rate. And if you think about it, that makes sense. If you have to go 100 miles and you're going to travel 50 miles an hour, it's going to take 2 hours. 100 divided by 50 is 2. So it's the same concept here, but the thing is we don't know how far they, or how fast they ran. We're not given the speeds that it took them, and we're not told how long it took them to do this race. All we're told is how long it was and how much further he was behind him. So what we're going to do here is we're going to call Jordan's rate, I'm going to label it R with a J below it, the rate for Jordan, and then R with an A below it as the rate for Amari. Alright, and so what we end up with is this equation. The distance that Jordan ran is 200 meters divided by the rate he ran it. We'll just call it RJ. And that's equal to, because remember this is time, distance divided by rate is time. This is the time it took Jordan to run the race. 200 meters divided by his rate. That was equal to 192 meters is how far Amari finished, how much he got done in the same amount of time Jordan finished. So we end up with this equation. So this is a fraction equal to another fraction. If you remember, when you were younger, you could solve these types of things by cross multiplying. If two fractions are equal, like that we are here, then the cross products are equal also. So if I multiply 200 meters times the rate Amari was traveling, I'll just write 200 times RA, we don't need the meters, and I'll set that equal to 192 times the rate that Jordan was running. So we get this equation. Now, what I'm going to do is I'm going to solve it for Amari's rate. I'm going to solve this thing for the slower runner. So I'm going to divide both sides by 200 here. And so what we end up with, I'm going to come back up here to the top. What we end up with is the rate that Amari was running is equal to 192 divided by 200 times the rate that Jordan was running. And if you're comfortable with fractions and converting them to percentages, 192 divided by 200 is 96. So 96 is, or 0.96. That's what we're saying here is Amari is running at a speed that's 96% of the rate that Jordan's running. So he's not 100% would be he's running the same rate. Like 105% mean he runs faster. anything under 100, 96% means he's running slower. So Amari's running at around 96% of the rate that Jordan's running. Okay, now, the second race. For the second race, Jordan's now going to have to run 208 meters. Okay, but what we're going to do, just to kind of cut to the chase here, we're going to let Amari finish the race this time. We're going to let Amari run all 200 meters. So for the second race, Amari's distance, distance equals rate times time again. Amari's distance this time is going to be 200 meters. We're going to let him finish the race. And we're going to determine if by the time he got to 200, has Jordan already gotten to 208, or is he more than 208 or less than 208? If he's equal to 208, then they tie. If Jordan's more than 208, then then he wins. If it's less than 208, then Amari would win. So we're going to plug in right here for the R. We're going to plug in Amari's rate, which is 0.96 times Jordan's rate. Okay, we're just subbing in instead of just RA. We're just plugging this in for it. All right, and then times time. Now, if you're looking, you see that if I divide both sides, this is how long. This is like the equation for Amari to run 200 meters. If I divide both sides of this equation by 0.96, what will I be left with? I'll be left with Jordan's distance equation, right? Rate of Jordan times time equals the distance Jordan ran in the same time it took Amari to run 200 meters. So that's what this second thing is on the calculator. 200 divided by 0.96 is 208.333333, bigger than 208. So what we get down here is distance equals a rate times time. Jordan's rate times time is greater than 208. So he's won the race. He's run faster. He's run a longer distance in a shorter amount of time. All right, so let's look at the questions that you're asked about this. All right, question A says, assuming both runners run at the same pace as they did the first race, who wins the second race? So Jordan wins the second race because that number right here, 208.333, is bigger than 208. So by the time that Amari gets to the finish line, he's run the 200 meters, Jordan's already run a little bit more than 208, and he was only 8 meters behind, so all he had to run was 208. So he's beat him again. Even though he offset by what he won by, he still wins. All right, then the part B says, well, what if he starts 3 meters back? Well, obviously, if he starts 8 meters back and wins, if he starts 3 meters back, he's still going to win. All right, and then suppose he starts 13 meters back. Well, again, if he starts 13 meters back, he's going to win. He's not going to win because this number's not 213 point something. It's 208 point something. So as long as he's more than 8.3333 meters behind, if he's more than that, then Amari's now going to win. So Amari will win the race if Jordan has to be 13 meters back. All right, and then D, how far does he have to be back for them to tie? That's just this 208.33333 that we get for Jordan's distance. If you just subtract the 200 that Amari needs to finish, then you get the 8.33. That's how many meters he needs to be back for it to be a tie. All right, so that's the way. It's not the way that the view an example would have you do it. The view an example has you just pick a random number out of the air. Say you ran it 40 seconds. I think it's easier in this case to work through it with a percentage. What percent of the speed that Jordan can Amari run, and then just work it out that way. It just kind of gets you that number that's needed for part D, but that number you need for part D can answer A, B, and C as well.